Let's talk about the electrons, shells, and orbitals. How electrons are arranged inside the atom. This is a little bit complex, and we have several layers of organization. As per the Bohr model, electrons are arranged in shells. These shells are defined by the principal quantum number given the symbol n. So, if you are talking about how the layers are arranged, you will see that electrons are arranged in layers or in shells. So they are given numbers 1, 2, 3, 4, 5, 6, and so on. This number has a certain name which is called the principal quantum number. So if you are ever hearing the words principal quantum number, you will know that the person is talking about the shell number of the electron. So if the shell number is 1, so the principal quantum number, which has a symbol n, is equal to 1. If the person is talking about the second shell, so this was the first, this is the second, so n is equal to, and so on. So if he is talking about the fifth energy level or the fifth shell, then the n is equal to 5. It's called energy level or called shell because for every shell or every layer of electrons around the nucleus, there is a specific energy. So if it is very close to the nucleus, there is a low energy, while electrons which have a higher energy are placed in shells or layers which are further away from the nucleus. So the further you move from the nucleus, the higher energy you will have, and the higher number and the higher principal quantum number. Let's imagine you are dividing the building of the atoms into different stories or different levels in which the electrons reside. So if you imagine the first floor is the first energy level or the first shell, which is the closest to the nucleus. Then after that, the second, and then the third, and then the fourth, and so on. Every shell is further divided again. So it's like you are having layers in the first shell and layers in the second, and so on. So for atoms that has more than one electron, the shells, because the hydrogen has only one electron, so it only stays in the first energy level or the first shell. But if you have more than electrons, the shells after that are broken down into other layers. These layers are known as the subshells. The subshells have different energies. The difference in energy between the subshells is less than the difference in energy between the shells. A shell with a given n number will have n subshells. So, for example, if you have n is equal to 3, this means that it has 3 subshells inside it, and so on. Here we have divided the places where the electrons might be available in the atom into shells, and the shells was divided after that into subshells. Then we can further divide the subshells into other regions which are known as the orbitals. So the subshells are made of orbitals. The orbitals in the same subshell have the same energy. So if it is even different orbitals, they still have the same energy. So let's remember together. We have divided the layers around the nucleus into shells, and every shell was further divided into subshells, and every subshell is divided into orbitals. But if you have an orbital, the different orbitals around the nucleus, it will still have the same energy. So different orbitals, as long as they are in the same subshell, they have the same energy. Where are the electrons staying exactly? The electrons are staying in the orbitals. and the orbitals can carry a maximum of 2 electrons inside it. So let's imagine that this is an orbital and these are 2 electrons. Whenever I'm trying to imagine the shells, subshells, and orbitals, I like to imagine them like the same building. But let's say that in the first floor, there is only one flat. So having one flat makes me imagine that there is one subshell in the side, the first shell. In the second flat, in the second shell, there are two flats, the first flat and the second flat. So how many subshells are there? There are two subshells. In the third flat, in the third shell, or in the third layer, or in the third floor, there are three flats. So there are three subshells. And in the fourth and up, I have four subshells, which I will call S, P, D, and F. And this one, I will call it the S flat. And here there is also S flat, here there is S flat and S flat. So the first flat I've called S, the second flat I will call it P. You have noticed that I did not find the P flat except in the second floor. Because in the first floor, there is only one flat or there is only one subshell. So the subshell names are S and P and D and F. Imagine that you have only one subshell in the first floor and we have drawn it in red color here just to make it distinct. And it contains only one subshell which is called S. The second floor or the second shell contains two subshells, the S and P. And in the third also, I will see S and P. And for the first time, I'll start to see the D flat. So the D flat, which we have drawn in the green, just to be distincted, is the third type of flats or the third type of subshells, which we can find starting from the third floor and up. You cannot find it in the first or the second, you can find it in the third and up. The same way we find the P flat starting from the second and up. What about the F flat? You did not see it in the first shell or in the second or the third or the fourth. So we have imagined that the story or the floor is the shell. We have imagined that the floor is the shell and the flat is the subshell. This imagines that you further divide the location in which the electron is available as an orbital. So we will say that the orbital is similar to the rooms. So every flat contains different rooms. The same way every subshell contains different orbits. When you are trying to locate the electron inside the atom, it's like you are trying to locate a person inside the building and you start asking him in which orbital you stay, in which subshell, in which shell. The same way like you ask a person in which floor you are staying, in which flat, and in which room. So if we imagine that the orbital is our room, it will carry a maximum of two people only, which we make it here similar to the two electrons. So if you want to know what is exactly an orbital, it is the region which is around the nucleus that you will find the electron in. Before, when we were younger, we were taking that the orbital is not called orbital, we were naming it the orbit. So we were imagining that you can find the electron around the nucleus in a certain line. So we were told that you will find the electron moving like that in this orbit around the nucleus. So it can be either here, or it can move to another place to be here, here, here. So it will keep moving only on this line. So this is called the orbit, and actually it's not correct because it's not like we are imagining that it can only be in this place around, moving in this orbit only. Actually, it can be in any other place. So orbit is not correct. The correct one is orbital. It can be here, 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 here. And you don't know when is the next place that the electron. There is no way to know where is the electron will be in the next place. So if you try to draw all the places that the electrons become on, you will get a drawing. So you will get a drawing, let's imagine that this is our nucleus again, and this is our electron. I've imagined it to be here, maybe here, maybe here, maybe here, maybe here, maybe here, maybe here. This is all the places that you might find the electron in. And at the end, if you keep drawing all the places that the electron might be found in, and you remove the wrong place, which we said is called the orbit, which is wrong, you might get a drawing which is very similar to a sphere. This is the orbital. So the orbital is the correct name. This is the place that you might find the electron around the nucleus. And as you see, the first orbital that we have drawn has a spherical shape, and we call this the s orbital. If you were asked what is the s orbital or what is the orbital, it is the place where you most probably you are going to find the electron around the nucleus.